Alright, here's what I want you to do now. This is the problem, the next problem in line here. I want you to figure out what happens to my total revenue as the price moves from $1 to $5. Oh, shoot. God. Alright, so this is the next problem on your slideshow packet here. And I want you to figure out what happens to the total revenue as the price moves from $2 to $8. And I want you to decide if this is elastic or inelastic. So go do that right now. I'm waiting. So your answers should look like the ones I've got right here. And hopefully you're scratching your head going, Mr. Sutton, I don't know if this is elastic or inelastic because your rule said, I don't know what happened to my total revenue rule here, but if the price and total revenue go in opposite directions, it's inelastic. If they go in the same direction, it's elastic. So I don't know what happened here. So we're gonna have a new rule that we add, because even though this looks like the first one that we did, in fact it is the same one, I just changed the numbers, and even though it looks like this one, it doesn't behave the same. Because here our price is changing, but the whole time our total revenue is staying the same. So this is a new rule for us. So I'm going to put this here. I don't know what happened to my old rule, but oh, there it is. I don't know why it did. Okay, whatever. So if the price changes and total revenue stays constant, we call this something different. It's got a special name. This is called unit elastic. Okay, so your price and total revenue, price changes, it goes up, it goes down, but the total revenue stays the same. So here it doesn't make as big a difference as to what price you charge. You're probably going to have to think about the cost associated with each level of production, each quantity, much more so to figure out the best play here, which is still true in the other examples as well, that you got to worry about your cost to figure out profit maximization. We're talking about total revenue maximization right now. So let me just point out why this is happening, and I chose the numbers very specifically here. If you notice, my price went from 2 to 4 to 8. What happened every time I changed my price? If you notice, I doubled it. It went 2 times 2 got me 4, 4 times 2 got me 8. And if you look, so 2 matched up with 16, $4 matched up with 8, and $8 matched up with 4. So if you go in the opposite direction from 16 to 8 to 4, what do you notice happening to your quantity numbers? While the prices are doubling, the quantities are splitting in half, exactly half. So they move in the same proportion. So I double my price, but I get a half the quantity. And this is going to serve as a good segue, because what we're really testing for here is the percentage change, how big the change is in the price versus how big the change is in the quantity. And so I will show you how to do this, because it's going to be what's called our midpoint method, and that's what comes next. But first, you are going to go work on some problems using your total revenue method. Okay, that's going to be your first task, is to do some total revenue problems. They are going to be on page number 2. Okay, and page number 2 is going to follow your slideshow packet. So, or it's going to be in the packet, it's going to be behind the slides. All right, it'll be labeled page number 2. It says elasticity on the top, and you've already done a little bit of it, hopefully, by deciding between the two matching pairs and deciding which is more elastic and which is more inelastic. So you will do that right now using your total revenue method. Go.